Okay, section 7.3, called Solving Multivariable Linear Systems, is basically solving a system that has three equations and three variables in it. And it requires similar steps to 2 by 2s, except they are a little more involved, and they're going to require that you pay extra special attention to detail, because if you make one little computation mistake in one of these problems, it can end up costing you a lot of time and aggravation. So just be careful. All right, the first one isn't too bad. If we notice, there are three variables, x, y, and z, but two of these equations already have simpler forms of the equation. So we're going to begin with the z equals 2. We already know z. So since z is equal to 2, what we'll do is go to the second equation and replace the z in that equation with the 2. So y plus 3 times 2 is equal to 5. Solving, I get y plus 6 is equal to 5. I subtract 6 from both sides, and I get y is equal to negative 1. All right, once I have a y, I also already have z, so I just need to find x. So at this point, I'm now going to replace the y with negative 1, the z with the 2, and I rewrite x minus 2 times negative 1 plus 3 times 2 equals 9. Solving, I get x plus 2 plus 6 is equal to 9. So x plus 8 is equal to 9. You definitely want to go slowly, make sure you don't make mistakes, because again, as I mentioned, that can cost you in the end. So instead of writing our answer as an ordered pair, what I'd like you to do is to write it as an ordered triple. So alphabetical order, x, y, and z, and then it's always a good idea to plug those values in, double check, and make sure those are the correct values that make the system of equations true. Okay, so number 2 is a little bit more involved. It doesn't start out quite as nicely because we don't have one of the variables solved for. But we do have one that has only 2 variables in it. So I'm going to put a box around that one, because we are going to try to make the other 2 equations look like this by using elimination. So here's what we do. We take the remaining 2 equations and we say, I need to get rid of the variable that was missing here. Since this just had an x and a y, I want to get rid of the z so that these 2 will just have an x and a y. So in order to do that, I have to look at the z's, and using elimination, I will multiply the top equation by 5 and the bottom equation by negative 3. So we'll do our work over here. I highly urge you to rewrite it. Don't try to do it all mentally. And also to multiply both sides and write it out on both sides, because students often run into trouble because they forget to multiply the right side of the equation by the number. So I rewrite 5x minus 10y plus 15z is equal to 45. And negative 6x plus 15y minus 15z is equal to negative 51. So I'm using elimination. I'm now going to add these 2 equations. I get negative 1x, or just negative x plus 5y. The minus 15z and 15z's cancel, and I get is equal to negative 6. So now I'm going to rewrite this equation, negative x plus 5y, underneath the other equation so that it's set for me to use elimination. Notice that these are the same, so I could either subtract or just change all signs and add. I typically like to do that. Mr. Divas, I think, likes to subtract, and that's up to you, whichever way you want to do it. Notice here I get these to cancel. I get negative 2y is equal to positive 2. Dividing both sides by negative 2, I get y is equal to negative 1. So we got our first variable. Once I've got the first, okay, I always like to circle it, put a box around it, and it gives you a sense of accomplishment. I'm now going to plug that negative 1 in for y in either of the equations. I'll go to the original equation, the blue one. So I've got negative x plus 3 times negative 1 is equal to negative 4. So I'm going to replace that y with the negative 1 that I had there. So working through it, I've got negative x minus 3 equals negative 4. Add 3 to both sides. I get negative x is equal to negative 1, or the opposite of x is equal to negative 1. And so x therefore has to be 1. Okay, 2 down, 1 to go. And they get easier as you go along because now I have 2 variables to plug in. So I'll go to either the first or the third equation so that I can solve for z. Let's pick red this time. I already did red. Sorry about that. Let's go with green. All right, so I'll pick the second equation. 2 times x, which is 1, minus 5 times y, which is negative 1, plus 5z is equal to 17. I get 2 plus 5 plus 5z equals 17. 7 plus 5z equals 17. So I get 5z is equal to 10 when I subtracted 7 from both sides. Slide this up a little bit here. And z is equal to 2. So again, I now want to put them in an ordered triple of x, y, z. So 1, negative 1, and 2. Feel free to check. We strongly encourage you to do that. Okay, now we're going to get to the next example, which is a 3 by 3, which doesn't have any help for us to begin with. So really, when you're looking at solving this, our goal is to take 2 of the equations and make them eliminate one variable so that I have 2 variables in them in the one equation. Then I have to take another pair of equations and eliminate the same variables. So again, I have a 2 by 2 that we are familiar with and know how to solve. All right, so if there's an advantage of using one over the other, it does help to take a look and see what might be beneficial. So if I look at the x's here, I see that I can just use the opposites. So I get x plus 3y minus z equals 1. And I've got x plus 2y minus 3z equals negative 1. So again, you can either subtract them or just change all of the signs on one of them and add, which is what I'm going to do. I get these to cancel. I get y plus 2z is equal to 2. And again, just be extra careful. Double check that you're not making any computation mistakes. Okay, so now I have to go back to the other two of the other equations and eliminate the x as well. So I can either use the first and the second or the second and the third. I'm going to eliminate by multiplying this one by negative 2. I'm going to eliminate the x with the middle one. So this one's going to be, I'll rewrite 2x minus y minus 2z is equal to 2. And then multiplying by negative 2, I get negative 2x minus 4y plus 6z is equal to positive 2. So when I add these two equations, I'm going to get negative 5y plus 4z is equal to 4. Again, I now have the same variables, y plus 2z equals 2, negative 5y plus 4z is equal to 4. And now I can try to work on eliminating either the y or the z. I would personally pick the y since I just have to multiply this top equation by 5 on both sides. So I'm going to get 5y plus 10z is equal to 10. Negative 5y plus 4z is equal to 4. Still have that one. Adding them, I get 14z is equal to 14. Divide by 14, z is equal to 1. Yay, you got your first answer. Okay, from here, work with one of these two intermediate systems, plugging in z as 1 or 1 as z. And so I will take the first one, y plus 2 times 1 equals 2. Y plus 2 equals 2. So subtracting 2 from both sides, I'm going to get y is 0. Okay, so I've got y and z. I just need x. So I'll go to the first equation. I have x plus 3 times 0 minus 1 equals 1. So I really have x minus 1 equals 1. So x is equal to 2. So our ordered triple 2, 0, 1. And again, we highly encourage you to double check by plugging those values in. All right, the next system, if you take a look at our next slide, we've got a 3x, lots of 3's here. Okay, I see some larger numbers, which again can be a little problematic as I go through. Notice if I just subtract these two equations, I could make all of these negatives, which I will do right here on this. If I made all these opposites, I can eliminate the x's right away. So I'm going to get these to cancel. I get 2y, 5y minus 3y, 9z minus 5z is 4z, and 0 minus 1 is negative 1. So we've committed to eliminating the x. Let's eliminate the x here then with these two as well. So you'll have to multiply this bottom or the middle equation by a negative 5, and the bottom equation by a positive 3. Okay, and then we're going to make sure we're extra careful as we do this because we don't want to have to start over if we make a mistake. So I get negative 15x minus 25y plus minus 45z is equal to 0. And then here I get 15x plus 27y plus 51z is equal to 0 as well. So as we go through, we notice using addition, the x's are going to cancel. I get 2y plus 6z is equal to 0. So now I'm back to having two equations and two variables, and I'm able to solve using subtraction, which is nice. So if I just multiplied the top equation by negative 1, then I can add these two. I get these to cancel. 2z is equal to 1. Dividing by 2, I get z is equal to a half. Okay, you might think, oh, it's a fraction. I know that, we don't usually have fractions with these. Well, it turns out that with 3 by 3 systems, we're probably not going to be giving you some, 37 over 52 type fractions. But, a half you definitely want to stick with because it's most likely going to just be a fraction at times. All right, so let's go ahead and plug in the z. You can pick either of these two equations. This is right here, so it's convenient. I will use this one. 2y plus 6 times a half is equal to 0. 2y plus 3 equals 0, subtracting 3 from both sides. I get 2y is equal to negative 3, so y is equal to negative 3 halves. All right, so we have our z, we have our y, and now it's a matter of solving for x. So I'm going to pick that middle equation. I'm going to get 3x plus 5 times negative 3 halves plus 9 times a half is equal to 0. I get 3x plus negative 15 halves plus 9 halves is equal to 0. 3x minus 6 halves, which is minus 3, equals 0. I get 3x equals 3, so x is equal to 1. So again, writing our ordered triple, I'm going to have a 1, a negative 3 halves, and a 1 half. Okay, I'm going to have to stop here, but I will get that last example on the next video, so look for a separate video for that.